Hello and welcome to section 4.6. In this section we're going to talk about graphing other functions besides sine and cosine. And so first thing you need to do is copy this table down, and we're going to fill in what the tangent of these guys are. And most of these guys I'm going to just remember them from the unit circle. And so just remember that tangent is sine over cosine. So that's kind of where I'm getting these from. And so if I do 0, sine is 0, cosine is 1. So at tangent I'm at 0, I'm at 0. At pi over 4, well, it's root 2 over root 2, which is 1. And then at pi over 2, I'm at 1 for sine and 0 for cosine, so that's undefined. And we'll find out that that actually ends up giving us an asymptote there. And then at 3 pi over 4, again, at 3 pi over 4, we have a positive sine but a negative cosine, so I'm at negative 1. At pi, I should be at, let's see, sine is 0, cosine is negative 1, which gives me a 0 there. And then at 5 pi over 4, I have a negative root 2 over root 2, a negative root 2 over 2, and a negative root 2 over 2 for sine and cosine, so I'm at positive 1. And then at 3 pi over 2, I have a negative 1 for sine, but a 0 for cosine, so again, another undefined, and an asymptote. And so then at 7 pi over 4, sine is a negative root 2 over 2, and cosine is root 2 over 2, so that's a negative 1. And at 2 pi, I'm at 0 for sine and 1 for cosine, so I'm 0. And so if I was to plot these points on a graph, which is what you need to do, you should get something that looks similar to this. If I just move this out of the way here, you can kind of see my graph. Now, this thing is going from 10 to 10. The y values are from 0 to 10 and 0 to negative 10, so these values are a lot smaller. But you can see here that what I did is my x values are the values you see on our graph. This is pi over 4, this is pi over 2, this is pi, and so on through with this. This is 3 pi over 4. And then this is 5 pi over 4. Oh wait, this was pi 3 pi. Wait, I did that wrong. This should be 3 pi over 4, and this will be pi, and then 5 pi over 4, and then we have an asymptote at 3 pi over 2, and so on. So you can kind of see where the asymptotes fall on here along with our values. So then please fill out the right to learn for the graph of the tangent function. The unique things I notice are, and so please fill that out in your notes. So characteristics of our tangent function is that we have a domain that would be almost from negative infinity to positive infinity. So we're going to say all reals except for where we saw those asymptotes, except at x equals pi over 2, that's where the asymptotes showed up, and then we have to somehow represent that for every pi value that they're being separated, because it was pi over 2, 3 pi over 2, which is adding a pi onto this. If I subtracted a pi from this, and so this n is just how many number of pi's over I am. The range of this function is going to be, if you saw the graph of it, if you remember the graph, it could go from negative infinity to infinity. And so our period of the function is just by pi. That's basically this value that I'm adding on over there. And then is this even, odd, or neither? If you remember, this is an odd function. And so that's really what we're talking about when we're dealing with these guys, when we're talking about tangents. So please get the graphs down. Please get these values down. So then we're going to talk about the cofunction of this. And so again, to get these values, please copy this down, and we'll make a graph of it again. So to get my cofunctions of these, remember that this is cosine over sine. And so that's where I'm just pulling these values from the unit circle again. And so when I'm at 0 for cosine, well, that's 1, but sine is 0, so that's an undefined. When I'm at pi over 4, they're basically the same values, so that's a positive 1. When I'm at pi over 2, that means cosine is 0 and sine is 1, so I get a 0. And at 3 pi over 4, that means that I'm in the second quadrant, which means cosine is negative and sine is positive, but they're the same value. They're still that root 2 over 2, so I'm at negative 1. When I put pi in, cosine is negative 1, but sine is 0, so it's undefined. And then at 5 pi over 4, 5 pi over 4 is in the third quadrant, which means that these guys are the same values. They're both negative, but it turns two negatives make a positive. They're both root 2 over 2, negative root 2 over 2, and so I get 1. At 3 pi over 2, when I plug them into the unit circle, at 3 pi over 2, cosine is 0, when sine is negative 1, so I get 0 for that one. At 7 pi over 4, we're in the fourth quadrant, which basically means being in the fourth quadrant that cosine is positive but sine is negative, and they're the same values, so I get negative 1. And then at 2 pi, when I plug in 2 pi, cosine is 1 but sine is 0, which is another undefined. So all these undefineds are our asymptotes that we're going to be looking at. And so you can go ahead and graph this by plotting these points. And if you look again, I did the same thing as I did before, that when I graph these, you can see that I'm starting at the positive and dropping down. And so the things that you may want to know about the cotangent function that are unique that I noticed are these. And basically make sure you fill in that right to learn, and just notice, just what you notice about them will be helpful. So then the last functions that we're going to talk about is what I want you guys to do on your calculator is in y1, graph sine of x, and in y2, graph cosecant of x. And so then you're going to fill in these graphs here, and I'll give you a little help. That here's what I chose for my sine of x. I made it a dark line so you could see sine of x. Cosecant of x is 1 over sine of x, so I graphed that with a regular line. And so when I graph those guys, using my values, this is 0, and this is 2 pi over here, and I'm counting by pi's over 4. And you can kind of see that this dark line is my sine, and the upper and lower lines are my secant, or my cosecant graph. Oops, these are supposed to say cosecants on here, sorry. Cosecant functions. And this would be cosecant also, cosecant function. And, oh yeah, and then, so what's going to happen with a cosecant function? Well, then you can kind of see what these are. These are our cosecant functions. We could have you also, it might be helpful for you also to graph for us y equals cosine of x in y1, and just do the same thing for this function. And you might also want to sketch a graph of what is the secant and answer these same questions. Get rid of the cos. But you will then get a graph, something like this. But just go ahead. So remember, I used my x values were from 0 to 2 pi, and I used my change in x as pi over 4. And so each one of these guys is counting by pi over 4. And then I went from 0 to 3. These were 3s in my y value to get this graph. So if you want to try to get the replica graph of this, you can. And so if you have any questions about this stuff, please come to class prepared to ask them, and we'll talk more about this in class. Thank you.